Alright, today we're going to be solving the linked list cycle problem on LeetCode, and the way we're going to be doing this is by Floyd's detection algorithm. So this algorithm is basically just a way that we can detect cycles by using 2 pointers. Some of you guys may have known it as the tortoise and hare problem or algorithm, and then it basically utilizes 2 pointers, one slow, one fast, and then we check to see if they ever meet again. So the way we solve this is, first we need to declare 2 pointers, and then we can start them at the same position, right? So we can create one slow and one fast pointer like that. Alright, now what we want to be checking for is that, first off, we want to be seeing if the fast pointer ever reaches an end. So if the fast pointer ever reaches an end, that would mean that okay, so first we do this repetition with the while loop, and then if the fast pointer ever reaches the end, that means it would be equal to a null pointer. So we need to continue the loop as long as the fast pointer is not null. And then we also need to check for whatever the fast pointer is pointing to. So we got to look at the next next node, and then we're going to make sure that one is also not null because the fast pointer is moving by 2. And this should work. Let me make sure this is all correct. While fast, okay, this looks correct here. And then alright, now oh wait, I just realized this is not correct. 1 second. Alright, that looks good. Alright, so now we want to update both our slow and fast pointers. So we're going to be doing slow first, and we're going to be moving slow by 1. So we can do it like that, where we move it to the next node, and then we're going to be doing fast. We need to update by 2, like this. Alright, this should be all pretty simple right now. So we go slow, we go to the next node, and then as it iterates, the fast will go to the one after, and then the fast will continue to be a lot faster. And if there is a loop, we need to check to see that the fast will eventually reach the slow again. So we can say if fast is ever equal to slow, then we can return true, because that means there is a cycle. And then I think outside of the while loop, if not, we can return false. Then this should be complete, I think. Let's double check all of this. This should be part of this class. Nice. Okay, let's run the code. Oh, I did a little typo. Let me retype this. Okay, we passed the first 3 test cases. Let's submit. Okay, nice. It seems like we actually were able to finish this successfully. With this algorithm, well, actually, let's go back to it so we can break it down a little bit more. Here, so with this algorithm, it is linear time, which is O of n, and then the space complexity is constant because all the memory is already allocated at the start, and we're not creating or deleting anything else, so it is constant. And then just to break through the code one more time, we can go through each line and talk about more what we did. So the first 2 lines here, we're just creating 2 pointers that are of the list node, and then we're assigning them to the same position to start with, because we want to make sure that they start the same, and then we change their speed kind of as they go. And then in order to continually update their positions throughout the linked list, we are going to create a while loop that first checks to see if the current fast pointer, which is going to be obviously ahead of the slow pointer, we see if it's reached null, or if the next one is going to be null, and then we check that here. And then if it's not null, then that means it's going to be either continuing the linked list, or it's going to be a cycle. So regardless, both times we need to keep updating our pointers to see for the algorithm to work, obviously. So we update our slow pointer by 1, we update our fast pointer by 2, and then if there is a cycle, then eventually the fast pointer will reach the slow pointer again because it is moving at twice the speed. So then if they're ever equal, then we can return true, and otherwise we can return false. All right, that should be okay then. Nice, thank you.